Thanks, Steve. And hopefully the live demo gods will be kind to me. So yeah, what we're going to start with is just show you some of the ways you can bring data from the web into Enso. We'll start with looking in some static sources, and then we'll look at how we can work with Web API. For those of you who aren't familiar with Enso, our kind of default component to bring data in from the file system is the data.read component, and we can use that exactly the same to bring in from a simple web request. So if I replace the local file system path with a URL to a CSV, then Enso will go out and fetch the data from the web and then load it into Enso. By default, it's looking at the content headers. So if the web server is replying correctly and telling you what things are, Enso will attempt to decode it. And in this case, it has read it correctly as a CSV, but you could also, if necessary, tell it the type that it was. So if we wanted to, we could say, actually treat this as a plain text file, and then it will load it in as text, or switch it to delimited, and then it will load it exactly the same as it would have done, detecting it as a CSV file. When we're making a change like that, in order to not be hammering web servers, we automatically cache the responses from a web request. They're cached for the life of your session when you're running. If you need to refresh it because the web data has changed, then you can hit the refresh button in the top left, which will rerun the workflow from beginning to end. Enso reevaluates in real time. So as you saw when I was changing delimited to plain text or back to auto, it's recalculating straight away and showing me what the result would be. Most modern web APIs generally tend to respond with JSON or XML, but concentrated mainly on JSON today. When we were building Enso, we were very aware that we needed to deal with web APIs and JSON as well as possible, and wanted to make it as simple and as easy as it can be to process and parse JSON. So let's go and have a look at what JSON looks like in Enso. So I'll add a new component. I click the input one and choose again data.read. I'll paste a quick URL in for a simple JSON object and fetch that one in. So if I now have a look at what's come back by opening visualization, because it's a JSON response and it's an object, not a table, we're going to show you it in its native JSON form. So we're showing what the JSON looks like. And if you look on the right-hand side, we've said that this is a JS object, so a JavaScript object in our terminology. That's because Enso has not done anything other than read it in and parse it at this point. We can then choose to do what we would like with the JSON itself. So in this case, let's say I wanted to get out the hobbies. I can just click on the blue link and a new component is automatically added to the workflow, extracting the values of that part of the JSON object. You can see there's a drop down has also been detected on the get, so I can click in here and say, actually, no, I wanted to get the address field, switch over, drill down and see the JS object representing the address part of the response. That's a simple JSON object. Let's have a look at a slightly more complicated JSON response. So again, I'm going to add another data.read component. I could edit the one that got there, but just leaving them up there so you can see what we were doing before. So this payload is a response, if I remember, from a Google Places API call I made a while ago, stored in an S3 bucket and hosted as a web page. This time it appears like we've got a table back because we're rendering it in a tabular form to make it easy for you to see what's in it. But if we have a look and change the visualization to JSON, we can see the raw JSON behind the scenes. And you'll note that we say it's a vector on the right-hand side. It's a vector of these JS objects. If we want to, we can look into this and see the data. So I could, for example, turn it into a table. I can use the toTable component there, after which it's now a standard table like we would have read from a CSV file, and we'll get the capabilities of filtering, sorting, and everything else you would expect on a table read in from a structure. Let's have a quick look on one more thing. If we go back to the table view, One other thing we could have done just to explore the data in this form is we see the blue links on the left. If we double clicked on it at this point, that would again added a component like you saw for the JS object before, and this would show us the underlying specific object at that row. So we can drill down and see the JSON inside that vector if we want to. Those are obviously static, simple requests. Let's now have a look and think around how we would work with our web API. In this case, we wanted to have a look at something that was slightly real-worldy. So the St. Louis Federal Reserve provides a fantastic online web resource called FRED, the Federal Reserve Economic Data, I believe, which has a great set of huge amount of economic data available. You need to register with it and create an API key, both of which I've already done. And then what I've done in Enso is in my cloud account, I can create a new secret. I'll just show you what the dialog looks like. Pop in a name and give it a value. And I've already created one with my API key, which will then be stored securely in Enso's cloud. And I can use the value within my workflow. However, when I'm using the value won't be displayed. The value is kept securely, and it allows you to kind of hide passwords and make sure they don't end up being saved in flat files and the like. As a quick experiment to show you how we could work with the FRED data, what we're going to do is we're going to have a look at the US and UK CPI data, bring the two series in and see if we can join them together and see what the data would look like. Up until now, I've been just typing in the URLs. We're now going to actually create a URL object. And the reason to do that is we want to build up the query string and use the secrets inside it. So let's start by adding a URI parse component. And this allows us to create a URI from a text value. We're going to get the data from the observations API of FRED. So I'll paste the root URI for that into here and hit return. This has created a simple URI object. At this point, it's doing nothing more than if it was a text value, but it allows us to then add query string arguments and build up the query dynamically or programmatically. For this API, FRED needs us to pass 3 different query arguments. The first is a file type, either JSON or XML. The second is an API key, which we've just created in the secret earlier. And the third will be the series ID, which we can get from the web pages we were just looking at. So let's build up this query and see how we make a request. Literally, I can just type in the key name. So in this case, file type with a value of JSON. And again, if we look at what comes out at that stage, what you'll see is exactly what you'd expect. We've added the extra part onto the URI. Clearly, we could have typed in the URI with the query string to start with, but we wouldn't be able to use the secret value if that was how we had done it. Likewise, we can now add the API key. But this time, I'm going to choose to get a secret from the cloud. And if I click on that, it'll give me a browse experience showing you the various keys in my cloud account, and I want to use the FRED API. If we now had a look at, tried to read that API back out, what we will see is the secret is not displayed in here. If we attempt to convert it to a value, the secret is replaced with _secret. When we make the request, obviously the secret will be then submitted by Enso and sent to the server as needed. Last argument we need to provide is the series ID. So if you're working with FRED, that's this lovely short string here. So I will copy that one into my clipboard and then put that in as a text value into the query argument. And now we've built our full URI. Last thing we need to do is now make a request to fetch it. If I come in here, there's a couple of options, fetch API and post API. Fetch API is for making requests that don't require us sending a body. Post would allow us to send some data to the API server as needed. So let's click fetch. Hopefully We now have a look. We've got a JSON response from Fred with all the data we're interested in. There's again quite a lot of information in here, but let's see what we want to get out. If I scroll down, the data we're actually interested in is inside the observation key. So if I click on the observations, again, it will add a new tab for me, allowing me to get the data. If I have a look, I can then see the data set directly into the table form, but it's still a vector at this point. So now I need to turn it into a table. If I use the toTable command, it will convert it, but I'm now going to use the extra argument that allows me to select what data I want to convert into the table. So I'm just going to convert the date and the value because I don't need the real-time start and end values. So I'll add those as two text values. Having done that, I can now expand it up and see the data. Now, the next thing I can see is there's some data at the beginning where it's just a dot. I'm going to use Enso's visualization tools to filter that out. So I can click on here and choose does not equal and say that it isn't equal to dot and remove that. Then within the table viz, there's a button that allows me to convert that into a component in the graph. So I can click that and it will automatically add the filter component into the workflow for me. So at this point, we now have the data as a date and value column, but if we look at the information provided on here, we still see them as text values, not as numeric values. So the next step is to convert these into numeric and date types, and I'm just going to use a parse component for that. The parse component will automatically try and convert all text columns, and if the column is convertible to a numeric type without loss of data, it will convert them for us. And in this case, it's then automatically converted this into a date and converted it into a float as it's recognized them. And we can see the various rough statistical data about those series at the moment. The last thing I want to do to this data set is normalize it so the value on the 1st of January 1960 is 1, and then rename it to give it the name of US CPI. So let's do that using a set component. I'm going to choose the formula mode of the set component, which will put us into allow me to type in an expression. And here I'm going to type in that I want to make the value divided by the first of the value, and then call that value. Oh, sorry, replace the value. Sorry, I put square brackets in. That will update the series and replace it with 1 at the beginning and scale it through the entire series. And last, I'm now going to rename this to call it US CPI. At that point, I've now processed the data, loaded in the US dataset. I now want to load in the UK dataset as well. And in order to do that, what I'm going to do is I'm going to zoom out so I can see the part we've just built. I'm going to select all the nodes from where we put the series ID in and copy and paste them. And that'll create a new branch. And all I need to do is update the series ID and the name. So let's get the series ID from the web page. I'll just grab it from clipboard. Change the series ID. Check that the value has indeed changed. Always good to make sure it did request. It has. And then rename the output to be UK CPI. We could have made this a reusable component, but that's for a more advanced talk later. Let's now have a look at how we can join the two series together. And that's as straightforward as adding a join component, connecting the two series into each other. I can specify it's an inner join, so I only keep where I have both points. And then that's it. By default, a join will join on the first looking to join the first column name on the first series, and because they match, it will match the date column automatically. If I then have a look, I've got a table of data, and if I switch it to a scatter plot, I can see a quick plot of them and see that the UK has significantly higher inflation over the last 65 years than the US does. That's a very quick guided tour of working with a simple API. Let's now look at one more example. I'm going to walk through connecting to a GitHub API, which requires us to send a bearer token in the header. For that one, we're going to need to use the data.fetch component. So let's go up to the top to a part I prepared earlier, which is getting me the token for the authentication. To authenticate with GitHub, I need to run a system command, and then I'm getting back from GitHub a short-lived token. That's just come in, and I can now use that. So I'm going to now build up a quick request, starting with a data.fetch component. Data.fetch is very similar to data.read, except it gives us a bit more control over a few of the extra things. So we can control the HTTP method. It defaults to get, but we can specify if we needed to send options or head. And likewise, we can build up the headers, which is what we need to do here. So if I add a new header, I'm just going to zoom in a little bit to make it a little bit bigger. I can then drop down and say that I'm needing to go through a bearer auth process. And then I can connect my token straight into the bearer place. You would also be able to click in here and find a secret, and you can also construct different secret values if you need to. So you can do more advanced things, but in this case, we're getting the token supplied to us from GitHub's command line. I'm going to look at fetching data from the Enso repository, just as a simple example. Place that one in, and again, we get back a nice big tree of data, massive JSON objects. Let's have a look at one of them and see what they look like. So GitHub's objects are huge. There's loads of data on every response line. But for this example, I'm going to looking at the tags that we have associated in our repository. So there's a tags URL. That's what we're going to look to work with. So let's go through a similar process to we did with the Thread API. I'll convert it to a table. And again, I can make my life a little bit easier by filtering down to just having name and tags URL. Then I won't have as much data to deal with in the table. You could bring it all in if you so prefer, but it makes life a little bit quicker. Again, I can then come in here and say I want to filter it where the name is Enso and add a new component. And I now have a single record with a URL that I'm going to request with. Next, what I'm going to do is I'm going to use a generate rows component and say I want to make the first 10 pages. So I'm going to create an integer range starting at GitHub starts at 1, and we'll request, let's say, the first 5 pages so we don't end up waiting for it for too long, and that I want to include the final point so that I get 1 to 5. Now I need to build a URL, and again, I'm going to use an expression to do that. I'm going to start with tags URL, and then I'm going to add to that the query string. And in this case, I'm going to build it directly in here. So I'll request 100 records per page, and that I want the page to be equal to the page. Now I forgot to give the row number a nice name, so I will go up and change that to call it page. And then I can put that one in as an argument on the end and call that URL. We now have a look at what we've produced. At this point, we've got a set of URLs ready to be requested. Last thing I need to do, pick the column that contains the URLs. And then I'm going to use a data.fetch many component. And this takes a list of URLs and allows us to request one at a time. We can also throttle it, so we can say that the minimum time between requests is however long. I'm not going to put that one in because I don't want us to be forced to wait for it to complete, but you could put that one in as needed to protect the APIs. Again, We need to put the bearer token in. I'll put that in first before giving it the set of URLs. Then I'll connect the URLs in, and you can see the progress bar moving across as it requests the paginated API. One slight difference that you'll see from the results we get here versus what we had in a simple fetch is fetch many automatically brings it into a table with an extra column put on the left called path, which will contain the URL that was used to request the page. It's converted the results into there, and we've now got the first 500 tags that we'd requested. If I go up and increase the number from 5 to say 7, then what should happen is it will relatively quickly flow straight through and now request the first 700 tags. Again, the live recalculation and the cache working there to make things a little bit quicker when we need to. That's a quick introduction to some of the fetch methods. And now I guess I'll hand back over to Steve and we'll carry on from there.